When it comes to Father's Day, dads want steak. And the experts at Omaha Steaks are making it easy for you to deliver uncompromising quality with gifts that are sure to make his day. Plus, get an extra $35 off with code THANKSDAD when you shop at omahasteaks.com today. But don't wait. Father's Day is June 15th. Shop now at omahasteaks.com and get an extra $35 off with code THANKSDAD. Minimum purchase may apply. See site for details.
From Nashville, Tennessee, this is Mysterious Matters, and I am the curator of mysteries. My name is Bob Bain, and welcome to the 5th season of Mysterious Matters, folks. Joining us today is going to be astronomer Bob Berman, and we're going to be discussing the James Webb Space Telescope, among many other topics this evening. Bob has a 2 to 3 minute show about upcoming day and night sky events called Strange Universe, and it airs on WAMC, which you can find by visiting mysteriousmatters.com/Strange Universe. And he has also written numerous books, which if you're interested in perusing any of those titles, you can go to mysteriousmatters.com/Berman, and that will take you to his Amazon author page. Now, without further ado, Bob, welcome to the show.
Well, it's a pleasure to be here. Thank you.
It's always great to have you back here to be discussing what's happening in the night sky, day sky, etc. This is our 3rd or 4th time together. I think last time we came together was back last year, and we discussed one of your books, which I believe was Earth-Shattering. And in that previous interview, we discussed how you had written about pandemics, but at absolute no point, did you even expect that we would be in the middle of a pandemic when your book was released, right?
Yeah, isn't that something? Yes, I know. We have the whole chapter about the famous Spanish flu of 1918, but all the experts, including my physician friends, all said, well, it'll happen sooner or later, but we didn't think it was going to be sooner, did we?
We certainly did not know what was going to be happening to us. I know you've done the research on previous pandemics in the past. At any other time, during any other pandemic, whatever the pandemic might have been, the Spanish flu, the bubonic plague, was there ever a time where they had seen such a huge amount of distrust in science and what they were being told about these plagues, about the deadly viruses? Were people as skeptical back in those days as they are in today's world?
No, I don't think so. There has been a pattern, and the pattern usually is one of initial denial by the government that it can't happen here because the local government, whether it's Venice or London or whatever city is starting to see the first signs of the current pandemic, for a long time there were recurring bouts of the bubonic plague or the Black Death. And the first thing is that the authorities don't want to scare people and ruin business and have ships not dock at their ports and all of the things that the merchant class would be upset about. So that's one reliable initial step, is denying that it's happening or about to happen, but not public mistrust. Usually people would flee. Famously, that's what Isaac Newton did when the plague spread to London, and he was already in Trinity College. And so the idea was, there was a Latin phrase, run fast and return slow. That was the advice in Latin for any plague that was just arriving at your town. And in the case of bubonic plague, it was predictable. They didn't know it at the time, but 13 days after a ship with rats infected with the fleas carrying the bubonic plague, 13 days later, the first human cases were happening. That's how long it took the fleas to jump from the the rats from that ship, from the new ships that were docking, to the local rat population. And then very often the local rats would die off because they were susceptible to the plague too. And then the fleas, although they did not prefer humans, they would start biting humans, and then on it went from there.
I know you said COVID-19 has been hurting you just like it has a lot of other people. You've had to cancel tours. You've had to cancel several other types of dates that you've had going on. But what have you been up to this last year, and what's happening this year? Is anything happening with your tours this year, or have they all been canceled?
No, we've been hurt by the plagues, of course. In fact, just yesterday, our tour company, which has been running tours to our secret places in north central Alaska to see the northern lights, we've been doing that almost 30 years, every single year, and we just canceled that yesterday. We had a fully booked up tour, but virtually everybody agrees and is happy to be simply carried over to next year's tour. But we've missed out now on total eclipses of the sun. We go to every one, but the last few years it's not wise to be with groups, and there are some countries that won't even let us in. So, it sounds like I'm whining and complaining, but I realize that the financial harm is very widespread, and I'm far from the only one to suffer from this.
Yes. Speaking of the total solar eclipse, I believe the next total solar eclipse, I was actually looking this up recently, the next total solar eclipse here in the United States will be occurring on April the 8th of 2024, and unfortunately here in Tennessee, here in Middle Tennessee at the very least, we're only going to be getting a partial solar eclipse, which is going to be somewhere around a 95% totality.
Yes, and unfortunately, a partial eclipse, even if it's 99%, unlike lunar eclipses, all the glory happens at totality. If it's not total, you might as well get nothing whatsoever, because any type of partial solar eclipse, no matter how deep it is, requires eye protection, because otherwise it can harm your eyes. Does not give you things like the corona, that is the sun's glowing atmosphere. Doesn't give you those pink flames that look like geysers shooting out from the edge of the sun that you could see so clearly during every total solar eclipse, especially using binoculars, which are perfectly safe to use during totality. And you see these pink flames leaping out of the edge of the sun, and the corona behind it, and the diamond ring effect when it's beginning and ending, and animals go crazy, and we found that people weep from the emotional impact of it. No other eclipse carries that kind of feeling. And partial eclipses of the sun, like you'll be getting in your area, don't do that at all. They're kind of interesting, but they're not life-changing. And totality is life-changing. So I'd urge all your listeners to seriously consider where and how far they must travel to get within the path of totality, because totality is everything. Now, that's not true of lunar eclipses. We're going to have a few this year, 2 good total lunar eclipses, and for the eclipses of the moon, totality doesn't matter much. A partial eclipse, especially if it's a deep partial, like 95%, looks every bit as good as totality looks. So the totality business is just for solar eclipses. Now,
Wait a minute, Bob. Is your house burning down?
no, I don't know what. I think my wife is cooking something, and that, of course, is the smoke alarm.
Yes. You mentioned the totality in 2017. Here in Nashville, Tennessee, we had that, and it was the first time I had ever seen a total solar eclipse, and it was simply spectacular. It was everything that you had described to me previously, except my wife and I, we did not weep, but it was it was something that is simply just so hard to describe unless you are actually there and you're witnessing it firsthand. It's hard to describe, but I can totally understand why people travel, why people actually travel thousands of miles just to witness a total solar eclipse.
That's right. Now you know. Having seen one, now you know why it's worthwhile. I think it's the most glorious experience that the human soul can ever capture, can ever experience, really. And once you see one, you understand it. You see that it's deeper than just the visual. There's something, I don't know, Bob, there's something that happens when the sun and the moon and your spot on Earth form a straight line in space. There's something beyond science, beyond logic, beyond the mere visual beauty of it. There are all those things, but beyond that, there is just something that happens that, boy, you got to see it to believe it.
Now, Bob, I know you have given tours over the years. You go to places like Chile and other locations around the world, from Alaska, who knows where else. But have you ever done or considered doing an astronomical cruise tour? And if you have done one of those before, what is that like?
Yeah, we've done a number of them, we being me, a cruise line that is two cruise lines, actually, Holland America and a British cruise line ran astronomy cruises based on lectures that I would give. And when Comet Hale-Bopp came through in the middle 90s, good quarter century ago now, the co-discoverer, Tom Bopp, and I, and the world's leading comet expert, Fred Whipple, and yes, the Charmin commercials were based on Fred Whipple's name, gave a cruise to see that comet just when it was first starting to appear. And we had a nice sold-out comet cruise in the Caribbean in March, and I think a lot of people were just using that as an excuse to get away from Cleveland or wherever they were from in March, because the truth is you could see that comet just as well from back home. But nonetheless, we offered that cruise, and it was a great success.
I've only been on one cruise, and that was back in late 2018, early 2019, because it was a New Year's cruise. And my wife and I, we were celebrating our 10-year wedding anniversary, so we went off to the Caribbean. It was a New Year's cruise, just like I mentioned, so that thing was packed. I wasn't exactly sure what to expect, but that darn thing was packed. We had roughly 3,000 or so, might have been 5,000 people on the cruise ship. We had a balcony room, so I would stand out on the balcony at night, just gaze at the stars. It was such a beautiful sight, but I was actually expecting to see something more than what I was just seeing, something more than just stars, because we were out in the middle of nowhere, in the middle of the ocean. But I guess you have to be certain places to be able to see parts of the Milky Way, perhaps see another galaxy such as the Andromeda Galaxy. But with that said, what has been the most spectacular place, or places actually, that you've been as far as the night view of the sky? Has there been one particular place where you've been to and the view is just so spectacular it blew your mind?
Yes, I'd say, and there's a few that compete with that. If you can get to a place far from any city, deserts work, for example, very well, and the air is dry, so there's no obscuring of the sky, and few, if any, clouds. Excuse me. Then just the night sky without any telescope or binoculars. You mentioned the Milky Way, and yes, the Milky Way splaying across the sky, which it does at its best in August, September, and October of every year. And then not only is there that glowing band of the Milky Way, but it breaks up into dark patterns that are actually vast, what we call absorption nebulae, dusty clouds of mostly carbon particles that are usually mixed with hydrogen, and new stars form from these. And those dark blotches in front of the milky glow of the Milky Way can be so striking by themselves that becomes the focus. In fact, there are cultures like the Maori of New Zealand that what they were looking for and what their mythologies revolved around were seeing patterns, imaginary creatures and mythical creatures made up of darkness that was superimposed in front of the Milky Way. But to see those dark patterns clearly, again, clear skies, far away from any artificial light. So I found deserts, the Thar Desert between India and Pakistan, especially the Atacama Desert that stretches from Chile on up into Peru, and the Sahara Desert. We had an eclipse that was in the Sahara Desert, right near the Libyan border. And those places are, to answer your question in a long-winded way, those places have offered the best skies I've ever seen. Also the great Persian deserts near the towns of Esfahan and Kerman in Iran. This was back when I was just out of college, and it was at that time safe to travel in Iran. They were our ally at that time.
Now, Bob, the last time we spoke, I actually pulled up an article about a missing gigantic black hole. The missing black hole should be in the center of the galaxy cluster Abell 2261, but when astronomers and scientists started looking, it just wasn't there anymore. It had simply disappeared. Did you by any chance look any further into that to see what might have actually happened to the black hole?
No. That's very intriguing, and if we mention that, then I apologize for not looking at that. I knew George A. Bell, for whom that galaxy cluster is named. In fact, one of his specialties, he used to be chair of the UCLA astronomy department before his passing, and he was a brilliant guy, a great guy, and his specialty were clusters of galaxies, and that's why there are catalogs that he started listing clusters of galaxies. Those are the largest structures in the universe. We all know that stars are bigger than planets, and stars form galaxies that, of course, are bigger than stars. Anything bigger than a galaxy? Well, a cluster of galaxies. We're living in one with only about 24 members in our little cluster of galaxies, and we're really just a subunit, like the suburbs of a much larger cluster, the Virgo cluster of galaxies that has 5,000 galaxies in it, and there are even larger clusters of galaxies as well, and many of them are cataloged as Abell followed by a number.
How many galaxies? If we had binoculars, if we had telescopes, or even by the human eye, how many galaxies might we be able to expect to view in the night sky?
Yes. There's one clear one with a naked eye if you're away from city lights. So any listener who is in the country, you don't even need desert-like conditions. As long as you're away from a major city, you can see the Andromeda galaxy, which is almost overhead at this time of year. It looks like a oval, egg-shaped, faint patch, but not challengingly faint. The main issue is needing a star chart so that you know where it is. If you can recognize the constellation Cassiopeia, which looks a little like an M or a W, which is high up, that's not far from it. If you happen to know the constellation of Andromeda, that would make it easier to find. But there it is, a little tiny blurry patch about as big as a fingernail. If any of you hold out any of your fingers at arm's length, your finger could just barely cover it up. So it's not that small. and you don't need any optical aid. Of course, binoculars or a small telescope will make it clearer, but it'll always be rather a blurry object. In fact, the word nebula means, something that's nebulous is blurry by definition, and they used to call them nebulae. It was called the Andromeda Nebula until we knew that these are actually what became in the 1920s called island universes, when it suddenly became clear that every star in the sky was part of our own home galaxy, named the Milky Way. And all of these were just like ours, collections of hundreds of billions of suns. And so they were called island universes for a while, which is, I wish that name had prevailed, because, galaxies is an okay name, but boy, the other one had a little poetry to it.
And speaking about binoculars and telescopes, we were just talking about total solar eclipses. I'm interested in this myself. Are there any specific telescopes or binoculars that could be used for viewing total solar eclipses, such as those with special lenses?
Yeah, binoculars are really the best for solar eclipses because you don't have to magnify very much to see it clearly. And, of course, you mustn't use a binocular except when the eclipse is total. That's the only safe time. If you point binoculars at the sun when there's even a little direct sun still shining, you will damage your eyesight. And one of the readers of Astronomy magazine wrote to me personally a few years ago to tell me how he had permanently damaged his eyesight doing just that. So when the eclipse is total, then any binoculars will work just fine. If you can afford it, the newer image-stabilized binoculars, mostly made by Canon, are wonderful. They're pricey. The probably the smallest one that's still useful are the image-stabilized 10 by 30s, and they're at a push of a button. It's amazing how it works. Gyroscopes compensate for the natural trembling of your hand. Everybody has a little bit of motion when they're holding binoculars, and this removes it. It's hard to believe that the telescope's optics could respond fast enough to actually compensate for the unsteadiness of your hand as you're looking at an object, but it does, and it makes it absolutely steady, and the steadiness adds to the pleasure of looking at the object. So whether it's for bird watching, terrestrial use, in other words, or for astronomy, such as a total solar eclipse, you really can't do better. If you can afford it, the cheapest models that work well, like these 10 by 30 Canon image stabilized binoculars, are about $500 or $600, which is a lot when you realize that you could get the same magnification binoculars without image stabilization from companies like Celestron. Has a wonderful pair for about $30 where the image is just about as good, but it doesn't have the image stabilization. It doesn't hold it steady. So you're certainly going to pay for that quality of being able to have the image stabilized. But once you have those, you can even use those in a moving car or in an airplane, and it'll get rid of any vibrations of any kind. So that's what we use. That's what astronomers increasingly use, rather than lugging a telescope around. And once you have good binoculars, they're a lifetime of pleasure because you can use them for anything. As I said, bird watching or spying on neighbors or whatever.
Now, I do know that you also own, now I could be mistaken, do you own or are you simply in charge of an observatory there in New York?
Yes. Here in the mountains, just a few years ago, I've always had an observatory not too far from where I lived, and as part of an organization when I started the Catskill Astronomical Society way back in the 70s, and we had an observatory, but I was the only one who took care of it or came up with the funds for it, so it eventually just became mine. But a few years ago, built one right here. I'm looking at it now as I look out the window, because I'm fortunate to live far from any large city, in a really rural area. I mean, out these same windows, we see bears walking by at least once or every month or two, and so it's very rural. Part of the world where people still don't lock their doors. And so I'm looking out in the distance. There's a meadow beyond, just outside my house, and on the far end of the meadow, there's the big white dome of the observatory. Observatories, of course, have the advantage that a telescope is always ready to go. It's polar aligned, so that otherwise the telescope has to be set up correctly so it'll track the object of interest as Earth rotates.
What kind of monitor do you have it hooked up to? Is it a large monitor? Is it projecting to a screen?
No, actually, Bob, I prefer the telescope's view when it's direct, when you let each little photon of light go directly into your eye and into your brain, rather than, some like to capture it using CCD cameras, and then it can be put into the image enhanced via various computer programs, and then, yes, it'll be on a screen. But some of us have spent enough time looking at computer screens. You know, the kids these days, that's all they do, is looking at screens. So there's something about the direct image. You know, we were talking about the vibes of a total solar eclipse before. I don't think I used the word vibes, but I don't live too far from Woodstock, and so that's how we still talk around here. So the feelings that you get from a total solar eclipse is beyond the beauty, beyond the scientific or intellectual pleasure. There's just something that it does to you from seeing it. I mean, there are some experiences in life that are like that, like falling in love, for example. It's quite different from what you might read in books, the real thing. So, yes, looking at Saturn with its rings, and over the years, especially some years ago when we always used to have college classes and sometimes a visiting church group or scout group or even elementary school group would come, and teachers were welcome to bring their kids, and seeing the reaction of people to Saturn with its rings. I don't know what it is about Saturn with its rings, but about half of all people looking through a good telescope at it say one of two things. They'll either say, "That's not real," as if there was some sort of image that had been put onto the telescope and they weren't looking at the real Saturn. Or people say, "Oh my God." Always one of those two. So I sort of get pleasure of listening for one of those two involuntary call-outs from people looking at it. But that's only when you see it yourself directly through the telescope and you see Saturn with its rings. If it's on a screen or if it's a photograph, and we've all seen, wonderful photographs that are far sharper than any telescope on Earth can show. For example, the Cassini mission that actually went to Saturn took pictures with much greater detail and sharpness. The Hubble Space Telescope took much better pictures of Saturn than any earthly telescope can do. And yet the photographs don't do it. Nobody looks at a photo of Saturn and goes, "Oh my God," like that. They just don't. But seeing it in person inspires that.
You could listen to a recording of your favorite singer, or you can attend their concert. I would imagine, I don't know for sure, but I would imagine there's a huge difference between simply listening to something that's been pre-recorded, such as this show, or listening to a recording of your favorite group, your favorite band, your favorite comedian, and actually being in the live element. I would imagine there's a huge difference, just like there would be a huge difference between looking at an image of a total solar eclipse and actually witnessing it firsthand.
See that we don't. I'm so far away from where there are concerts that it's been. I have to think back to my youth almost to remember concerts. So I don't know if that's true. But when it comes to eclipses, there are actually bad things that happen photographically. For example, we mentioned the diamond ring effect. Now I know you saw it when the eclipse happened in Tennessee a few years ago. That just when the totality part is about to begin, and just when it ends, there's one bit of direct sunlight that shines through some lunar valley, and that produces to the eye, when you're looking at it directly or through binoculars, produces a pinpoint of intense light. And all the rest of the sun is eclipsed. So you still see the corona, the sun's atmosphere surrounding the whole thing. You can see the prominences, the pink geysers of flame coming out of the sun's edge. And then dominating all of them is this incredibly bright but tiny pinpoint of light. And that's the diamond ring. It's very impressive in person. Now, the reason I'm mentioning that is with photography, it's so bright that it's overexposed. And instead of a pinpoint of light, it's a large smudge of light on the edge of the moon. And because it's so large, because of the overexposure that's inevitable, it carries a different impact. In fact, it carries no impact at all. It's a different experience than something so tiny and yet so brilliant in the image. So that's another reason that the in-person view is very different from any photograph.
You just mentioned the Hubble Space Telescope. They just launched the James Webb Space Telescope and has finally opened up. Would you be able to tell us what the biggest differences are between the Hubble and its successor?
Well, the size. The Hubble telescope is just a 94-inch mirror, and this one is several times larger. And when you have a mirror that's several times larger in diameter, it's the square of that in terms of the light gathering surface, because you use the formula for the area of a circle rather than just talking about the radius or diameter of the mirror. So it's a much, much larger telescope, but on top of that, it's optimized for the infrared. Now, the Hubble telescope was a visual telescope. This is infrared. Now, why infrared? Because as the universe expands, every bit of light in the universe is stretched out by the stretching of space. So as you look farther and farther away, the expansion is faster, and light traveling through this stretching space have their light rays stretched so much that the light is redshifted all the way from the visible wavelengths that our eyes see into the infrared. So an infrared telescope is perfect for looking at objects that are truly far away, because they just really can't be seen, certainly can't be seen well, with an ordinary visual telescope like Hubble was. So that's one big advantage of an infrared scope. And the other is that infrared penetrates opaque, dusty clouds that are on the edges of galaxies. We were talking about that earlier, the pattern of dark blotches in the Milky Way. If you live in the countryside away from cities, you can see those dark blotches in front of the glow of the Milky Way. Well, an infrared telescope can see right through that as if it weren't there, and see whatever galaxies are hidden from view for earthly-based telescopes or even the Hubble telescope. So James Webb has several advantages like that.
Now, since it is an infrared telescope, what sort of images is it going to be sending back to us? Is it something that we would be able to, like yours truly, an average person, would we be able to look at those images and know exactly what we're looking at?
Yes, fortunately, the capability also extends into the visual, so it will also give us visual images. And then in addition, the infrared images can be translated by computer into visual images. So we will be able to see things we recognize.
What sort of time frame are we looking at between the time it actually gathers that information to the time it transmits that information to NASA?
Well, the light travel time from the moon, this is well beyond the moon. It's about 1 million miles from Earth. So it would be a matter of seconds, less than a minute. But I'm going to do a quick estimation of about a 10-second travel time. It'd be something along those lines. And you're right to ask questions about involving time, because the two most famous things that James Webb people are looking forward to it providing is, number one, some in the media are talking about it seeing the birth of the universe, and the other thing is people are talking about it being able to detect gases on exoplanets, meaning planets that go around other stars, not our own sun. And there are certain gases that would be the signature of life. Oxygen is one of them, because the only reason we have free oxygen here in Earth's atmosphere, about 21% of our air is oxygen. And if there was no life, there would be no oxygen, because oxygen is always pulled in by almost every other element. Everything loves oxygen. So oxygen binds with iron to form iron oxide, rust. It binds with silicon, a very common element to form silicon dioxide, which is quartz and sand. It bonds with carbon, as we all know, to form carbon dioxide. And so because it bonds with everything, there'd be no free oxygen left. Why is there free oxygen in the air when everything wants to suck oxygen in and combine with it? And the answer here on Earth is plants. Plants take in things like carbon dioxide and then give off oxygen as a waste product. And so it's only because we have a copious amount of plants here on Earth that we have an atmosphere with all this free oxygen. So if this holds true elsewhere, and we believe it would, then if we detect oxygen in the atmosphere of a planet going around another star, that's a very good indication that there would be life there.
Yes. Now, speaking of planets going around other stars, let's go somewhere else for a minute. I have in front of me an article. I'm not going to read the whole thing, but essentially it's talking about rogue planets. It says, the moon of planets that have no star can possess an atmosphere and retain liquid water. Astrophysicists at LMU have calculated that such systems could harbor sufficient water to make life possible and sustain it. What are your thoughts about rogue planets and possibly the moons of those rogue planets being able to sustain life without being attached to a star?
Well, yes, it's possible. And the problem is always that when you get from theoretically possible or conditions that would make it possible to happen, you don't know whether it has or not. Going back to James Webb, for example, let's say it does discover just this. It discovers that in the atmosphere, because it should be capable of spectroscopically detecting the components of an atmosphere of planets around other stars. That's an amazing capability. So let's say it does that and shows us that a star relatively close by, let's say just 100 light years away, which is close by celestial standards, and we find that it has free oxygen, then there's a good likelihood that there's life there. But here's the problem, Bob. Now we know that there's likely life on this exoplanet. We cannot know anything else about that life because the planet, at best, is just a dot through James Webb. it won't show any detail, let alone seeing life. In fact, even if we were to orbit that planet, send a space probe, we probably wouldn't see individual life, just as our own satellites, like the ISS, the International Space Station, when it looks down towards Earth, it doesn't see individual animals. So the only way we would know for sure is by sending a space probe there, and then probably a lander from that space probe, and then looking around and broadcasting via radio beams, in other words, televised images from the surface, and then we'd know what was there if we got lucky, unless it landed in the wrong place, like the middle of an ocean and just sank. But so let's think about this. So let's say James Webb discovers free oxygen around a planet orbiting another star, a close-by star, only 100 light years away. Remember, our own galaxy is 100,000 light years from side to side. So 100 light years would be a pretty close star. So we know nothing more. We can't know anything more about that life. Is it just plant life or animal life? Is it just microscopic life that's giving off the oxygen, like phytoplankton? Or is it something that large enough to see? If there is animal life, are they intelligent? Now, we'd want to know these things, of course. But to find out, we'd have to send a spacecraft to orbit it and then a lander. Now, to go even 100 light years, unfortunately, using our fastest rockets, would take about 5,000 years. So if we got to work really quickly building the fastest rocket we could possibly build, it would be 5,000 years before it gets there and provides us with answers. Now, what do you suppose will happen during those 5,000 years during which we know there's life, but we know nothing about it? Just thinking about human history and thinking about the last few years in America, and well, we don't want to get political on this show, but certainly, let's put it this way: a certain percentage of Americans have certainly revealed themselves to be non-scientific or not very smart about things, or don't want to insult people, but we can pretty much count on during those 5,000 years we're going to get New Age crazy people who claim that they're receiving signals or vibrations from this so-called intelligent life species, and that they're getting messages from this planet that we know has life, but we don't know anything else about it. But, there's going to be people like here in my own beloved Woodstock, a few miles down the road from where I'm speaking to you from right now, who will claim that they're getting messages and signals carrying various advice to Earthlings. There'll be the religious crazies. There'll be even science crazies. There'll be people that are actual scientists who come up with theories and ideas that are not sufficiently supported by facts and observations, or are not supported at all, who will claim this and that and this and that, and this is going to happen. There'll be crazies of all stripes. For 5,000 years we'll have to endure this until we get, finally, some additional information and find out the truth about what's there on that exoplanet. So this is what James Webb can bring us. The first step, finding out that there is life, and then brace yourself, because we'll have thousands of years while our spacecraft tries to make the trip. Hopefully our rocketry will increase in speed such that maybe we can make the trip in only 1,000 years.
And speaking of individuals, scientific individuals who believe certain things that might not go along with mainstream science or scientific theories, there is a Harvard professor. His name is Avi Loeb, and he is the head of the Harvard Astronomy Center. He has come out and said that he believes that a meteor, an asteroid, whatever it might have been, the name, I believe, I could be mispronouncing it, the name is Oumuamua, that it might have actually been an advanced technological light cell, a probe of some kind that was sent to seek out, much like we do, to seek out life in other galaxies, life on other planets. And I know that a lot of scientists, a lot of his peers, have ridiculed him. Some have stuck by him. But what are your thoughts about his ideas, his theories that Oumuamua might have been an extraterrestrial probe?
Well, here's the problem. Let's let our listeners decide on what's likely there. Oumuamua is one way to pronounce it. It was a long cigar-shaped object looking a little like a piece of dog poop, actually, swept into the solar system. This was just a couple of years ago at a speed and trajectory that showed us that it did not come from here. When we see comets or asteroids coming close to the Earth or the Sun, in the past they've always come from this shell of material, mostly icy material, called Oort cloud, or from a closer in repository for these called the Kuiper belt. And just tracing back the orbits of these objects, we've known that it originated in one of those two places, whips around the sun, heads back out again, and maybe its orbit is such that we can calculate that it comes close to us and the sun every, let's say, 50,000 years. We get that periodically. We just had one last year, Comet Neowise, and another one, Comet Leonard, much more recently. And no mystery there. What was strange about Oumuamua, or as I say, there's different ways to pronounce it. It's a Hawaiian name, named because it was discovered in Hawaii, so the astronomers there decided to give it a Hawaiian name, is that its speed and trajectory showed that it did not originate here in our solar system, even on the edges of our solar system. Rather, it came from interplanetary space, and tracing back its orbit showed that it originated near the bright star Vega, a famous star that too many people mispronounce as Vega, but it is Vega. And so this was only the second time that we'd ever discovered anything in our solar system that definitively came from outside the solar system. So here it is entering a solar system, captured by the sun's gravity, whips around the sun, and that's when it was first discovered. So we didn't even see it until it was outbound, and now here's where the story gets strange. As it was leaving the sun always pulls on such objects by its own gravity and slows them down. They still escape from the sun, but because they have plenty of speed, but they slow down, have to, because the sun's huge gravity is pulling on it. But in this case, this object sped up. Now, how can you possibly have an object leaving the sun's vicinity that is speeding up? Normally, you'd have to have rocket motors on it. So those, like this Harvard guy who said that this is a sign of intelligence, that it's an artificial craft of some sort, that was the main reason for arguing that this thing was speeding up, almost as if it had finished its reconnaissance mission of our solar system, and then once it was leaving and whipped around the sun, now it might as well speed up on its way back. So that was weird. Now, other scientists have said, well, it's not the first time we've seen objects speed up, leaving the sun. If there's outgassing, in other words, the sun itself can heat something so greatly that the object has essentially miniature geysers, plumes of gas that are being released. And if that is the side of the object facing toward the sun, well, then that'll push on it like a rocket engine, like a rocket's exhaust, and speed it up as it's leaving the sun. We've seen this a few times before, so it's not unique. So the majority of scientists like to use Occam's razor, which you might recall is the principle that the simplest explanation is usually the correct one. For example, if your car doesn't start in the morning, yes, you could say, well, maybe a meteor hit it during the night and wiped out its the electronics so that's why it didn't start. But the simplest explanation is that it's out of gas or the battery's dead or something like that. And usually you start with the simplest, most likely explanation first, and if that proves to be wrong, then you go to increasingly more far-fetched examples. So most scientists say, starting out saying that this thing is artificial and is an alien spacecraft is just not the way we do science. But we could find out. Here's where I'm personally disappointed, because if we really wanted to find out, we could hastily build a spacecraft that could catch up to this thing. It's still not too late. We could launch a spacecraft and use the gravity of Jupiter or the Sun to whip it around, add speed to it, and it's been calculated that we could catch up to it in about 5 years. At least this was true a year ago. Now maybe it's had a bit more of a head start and it would take more than 5 years, but it would be just a matter of a few years. Catch up to it, photograph it up close, probe it up close, and find out for sure whether it's a synthetic object or whether it's a natural piece of rock. And we're not doing that, but I think it would be worth the money, don't you?
Oh, yes. And you had just mentioned a meteor or something might have struck a vehicle, caused it to wipe out the electronics. That actually brought to my mind solar flares. I know, I guess it was, 100 years ago, 200 years ago, whatever it might have been, but it happened before we were as technologically advanced as we are today. Because in today's world, we really do rely upon satellites and electronics, GPSs, for everything that we do in our daily lives. But we know that at some point, we're going to have another gigantic solar flare hitting the Earth, hitting us with its plasma. But with that said, what's going to happen to all of our electronics, the GPSs, everything that we rely on in today's society? Would those be completely wiped out?
Well, they could be, Bob, and you're so right. The event you're alluding to is called the Carrington event. It happened in 1859, and at that time, a British astronomer, he was even an amateur astronomer, and it turned out there was another astronomer too, using a rather small telescope, saw a flare from the sun that was brighter than anything that had been seen before, and it turns out to have been the most powerful explosion or flare ever observed on the sun. We had another one in 1921 that wasn't as powerful, but still set a railway control center on fire. But the Carrington event back then was so powerful that a few days later, when material from this flare, including different forms of energy, reached here, at that time the only thing it could travel through, the only metal objects it could travel through were the newly installed telegraph lines. And it was so powerful that there were telegraph operators that received shocks, that were knocked from their seats and found to be unconscious on the floor from this Carrington event. And the event later in 1921 started fires in New York City, and so you're quite right. If we had another one of that ilk, and sooner or later we'll get that, it definitely could damage or destroy our satellites, GPS, and otherwise, and do a lot of damage on Earth. In fact, lesser flares we look forward to them on our tours. By the way, people who are interested should contact Special Interest Tours. That's the company, and check out the dates and the prices and see if any of these tours match their your desires or your schedule. But we like these events on the sun because they're followed by spectacular colors and aurorae here in the skies of Earth. But too much of a good thing is too much of a good thing. You get too powerful a solar storm, and yes, it can produce that kind of damage. In fact, a government panel that was convened after the 1921 event decided that we could lose all of our electric grid, and that it would cost, in today's dollars, trillions of dollars and 2 years of work to restore our infrastructure to what it had been. So some are saying, well, we should harden it. We shouldn't wait till it happens. We should build in protections, the equivalent of circuit breakers. We should build in protections starting now in case something like that happens. But the problem is we humans tend to not want to spend a lot of money on what's called high impact but low probability events. Low probability in any given year, but high consequence if it does happen. And our tendency as humans is not to want to spend a small fortune to prevent that from happening. So realistically, it'll happen sooner or later, and then we'll have to deal with it.
Yes, we will. Now, during one of our last shows together, you actually shared that you were a pilot yourself. If you were to fly a plane, and that plane was hit by a gigantic solar flare, just imagine the gigantic solar flare that would wipe out electronics everywhere, what would happen to the plane?
Well, nothing in my own plane, because it's a small four-seater plane that's not too reliant on electronics. We have, of course, full instrument panel, but the kind of mischief and damage that solar flares and coronal mass ejections, or CMEs, do are generally things like electrical currents that travel through the ground, through things like pipelines, like the Alaska pipeline would be very vulnerable, and through power lines and electric lines, and do that and damage satellites, the electronics and satellites. In an individual plane, the damage would be minimal. I wouldn't be worrying about that.
Another thing I had on my mind about you being a pilot, the Airline Pilots Association has actually raised concerns to the FCC about the upcoming deployment of 5G from AT&T, Verizon, and a few others. What type of interference could 5G be causing to those planes or their navigation system? What exactly are those pilots in the Airline Association? What's the main concern?
Well, the real problem is that I believe it's Elon Musk and several others. You can actually see these things being deployed. The idea is that thousands of small Earth satellites are now being launched, hundreds at a time, that are circling the Earth, and the idea is that everybody will get signals from these things that'll let your cell phones, including 5G usage, work anywhere. Even if you're in the middle of the Amazon jungle, you'll never be out of cell phone range. Now, I think that it would be pretty easy to have remedial electronics that would counteract the effect of it. I'm not sure it's 5G per se, or just the strength of the new signals that will be coming from these satellites. But again, I'm a private pilot and own a private plane, a four-seater, that's quite different from the airline pilots that have much more electronics, and I frankly don't know what electronics of the plane could be deleteriously affected by having extra strength GPS 5G signals, but I don't doubt that there would be some electronic remediation that could be done that would keep it from being a big problem.
Well, Bob, as an astronomer, with more and more, let's just call it space junk. I mean, sure, some of it is useful for us, some of it we use on a regular basis, but with more and more of that space junk being put up into the orbit, how does it affect you as an astronomer? How will it affect those of us who love watching or looking at the night sky? Because eventually, instead of seeing stars, instead of seeing the planets that we would expect, really, we're going to see thousands, tens of thousands, perhaps millions of satellites instead of stars, right?
Yes, and astronomers are upset about this. You're quite right. These new ones that are being launched, thousands of satellites whose only purpose is for cell phone signals to reach every part of the world. But regardless of what the purpose is, we'll see moving dots of light crossing the sky. For those of us who watch the sky just for the aesthetics and the beauty of the sky, some are saying, well, shouldn't we have had a voice in all this? I mean, what can corporations do and what can't they do? For example, if there was some way to ruin sunsets or build something on mountains so that the mountains were spoiled, does beauty and natural beauty in particular, does that matter anymore? Or can any entity, any corporate entity that they want? And so that's that's a question. Fortunately, the good news is that satellites are primarily seen during the first 90 minutes after sunset and then the 90 minutes before sunrise, because they don't have lights of their own. So they're only seen when the sun is shining on them, and that doesn't happen in the middle of the night. So there's every night, even with all these satellites, they will not be seen roughly between 10 o'clock at night and 2 or 3 in the morning, depending upon whether it's daylight saving time months or not. So it won't be a constant thing. It'll be, as I say, about an hour and a half from nightfall on, and then it'll stop. And then again, another hour and a half before sunrise. That'll be the period when you'll see these things. And if you want to look for them, same thing applies. Look for them. Once you started observing satellites, you start to see that you can learn a lot about them just from seeing the way they move, whether the light is steady or whether it's winking on and off a bit. For example, military spy satellites almost always have polar orbits, so they're moving north to south or south to north across the sky. If they're still functioning, the light would be steady. If they're tumbling out of control, which many are doing, then they're no longer functioning. They're defunct satellites. They're older satellites that are no longer working. And so you can actually, and some people have a lot of fun with a group of friends telling them all about what that satellite's doing just by noticing a few things about it.
Well, Bob, I definitely appreciate that you came on air with us this evening. Now, just like I mentioned at the beginning of the show, you have a show yourself called Bob Berman's Strange Universe, which airs on WAMC, I believe, and on that show, you discuss all sorts of day and night sky events. Is that correct?
That's correct. People can get that either locally on their public radio station, and if you're in an area where you can't get that, you can certainly get that on by going to, just as you said, WAMC.org, and then under the site menu, look for Strange Universe, and you can hear each week's show. So that airs. It's only 2.5 or 3 minutes. In most places, it airs on Sunday mornings.
As we're heading into 2022, possibly 2023, I know COVID is still an issue, still a problem for a lot of people, including your tours. But what are you most looking forward to in the day and night sky this year?
Well, I always look forward to returning to the Atacama Desert because the skies are so beautiful there. You really don't need binoculars or a telescope. Just the sheer beauty beauty of seeing uncounted stars and the Milky Way, plus because it's southern hemisphere, seeing things like the Southern Cross and the Magellanic Clouds and some of the glories that you can only see from south of the equator. So I always look forward to that. We do one of those once a year or so, the Atacama Desert tours, plus the desert itself is fascinating in a lot of different ways. And then we'll have an eclipse tour to Bali in 2023. That is just next year. And then, as you mentioned earlier, the great 2024 total solar eclipse that'll be visible from many parts of the United States, from Texas on up to Cleveland, Buffalo, Rochester, and then over Lake Champlain, Burlington, Vermont. Then the shadow will continue to the northeast to sweep across New Hampshire and Maine as well. So that's a good one on April 8th of 2024. Our own group is actually going elsewhere. We're going to be taking people to a ranch in Texas, just because we always go where the skies are most likely to be clear. And the Northeast, anybody who lives in the Northeast knows that in April, you sure cannot count on clear skies on any given day. So maybe a 50-50 chance of clear skies. I hope so, that it's clear for all the millions of people who look for that in the afternoon of April 8th.
I know you were originally scheduled to do a tour of the Northern Lights. I don't remember the exact date, but was that something you were able to do, or has that been canceled as well?
Yes, we've canceled everything the last couple of years because of COVID, unfortunately.
I know for a while there, it looked like it was getting better. It wasn't as bad as it had been, and people were either getting vaccinated or they had already been exposed. So the immunity levels were fairly high, and it looked like at one point that COVID was going to go away. So, and life was getting back to normal. So I was just wondering, actually, if at any point during that time you were able to do any of your tours.
No, we've actually canceled every single one, even the ones we were hopeful of. And then there'd always be a new variant, first Delta and now Omicron. And you know, we don't want to put anybody's health or lives at risk. And the outdoor parts of these tours, you know, standing outdoors seeing an aurora would be quite safe, but getting there, putting, you know, people, and then we have meals indoors together, and there's always a goodly number of our guests who would want to go ahead and do it anyway. So it's delicate, you know. It's a balancing act. You don't want to cancel it unnecessarily, but hopefully this will be the final year, and all those tours that have been scheduled, everybody has been invited to just be shifted off one year, and almost everybody has said yes. And no, don't give me my money back. Just keep me on that list for next year.
And I have to imagine, now I'm not an astronomer, I'm not in your shoes, but I would have to imagine that even those individuals who may pay for a tour, whether it's thousands or tens of thousands, whatever it is, I don't know what your tours cost, but even during COVID, you don't know who's vaccinated, who's not vaccinated, whether they'll wear a mask or they won't wear a mask. And if someone's spending that amount of money for a tour, would you feel uncomfortable telling them you can't come because you didn't get vaccinated or you're not going to be wearing a mask? It's one of those situations where it is such a tough situation because they spent the money, and because they're not willing to do something to follow the safety rules to provide safety for everyone else, you have to exclude them.
It is, and you're quite right. Fortunately, I don't have to. It's not my company. I do the lectures, and they use my name to attract the readers, and both the magazines that I'm an editor of, or the books that I've written, to lure people on the tours. But I don't deal with the money or decisions like that, fortunately, because I'd be bad at it. And I'm glad I don't have to. But again, it's special interest tours for people who want to see what's coming up, what's being offered, what it costs, what are the dates, and where we're going. And it's always an interesting group of people. I've been so impressed by the people who do it. Goodly number of teachers and retired teachers and doctors and you can imagine people who are interested in nature and things that are off this planet are not your ordinary people. They tend to be smart and fun-loving, and a lot of friendships have been made on them.
I can imagine back in those days when we could actually go outside, and it just seems like it was many years ago now, a different lifetime. Actually, I definitely appreciate speaking with you. It's always interesting. I'm not an astronomer. I'm not a scientist, but that doesn't mean I don't have an interest in what you do and what other individuals do. That's why I do the show. And I'm sure that's why you and others come on shows just like this one, to reach out to other individuals who would be appreciative of your view, of your perspective.
Oh, thank you. I actually try to keep my views and perspectives to a minimum because...
you don't want to alienate certain people?
Yeah, and astronomy lends itself to that, to the big issues, the big questions. People are always asking astronomers whether they believe in God, whether they've seen objects out there that make them think they're aliens, and we get these questions all the time. And I try my best to just duck them and not answer, just on the because I do a radio show also, live for NPR during Weekend Edition, and when we get callers into the show, I figure I don't have a microphone in front of me just to give my wonderful wisdom and views on philosophy or religion. I have the microphone to talk about science and astronomy, so that's how I like to try to keep it.
Now, before we let you go, Bob, are you writing another book? I know you've released several over the years. Is there another one?
Well, the ones that just came out are, you mentioned Earth-Shattering, that came out last year, but the newest one I co-wrote with Dr. Lanza, Robert Lanza, who's famous as one of the first people who did cloning and developed cloning. And because of that fame, I think his name is golden in some circles. So with a European physicist, and Bob Lanza, and I as the third author, we created a book that just came out called The Grand Biocentric Design. And biocentrism essentially is a principle that didn't start with us. It was really the quantum theory originators, mostly Werner Heisenberg and Niels Bohr and the rest, who were really pushing for that idea. And that is all of the experiments that show that our own consciousness as observers figures into nature, that experiments change and particles like electrons change their nature depending upon whether they're being observed and how they're being observed, and the information in our minds. It sounds impossible. It sounds very new agey and hippie-ish and stuff, but there was no getting around the science behind it, that knowledge in our minds actually changed whether the electron was a wave or a particle. And at first this just seemed like an oddity that you would just say, well, who knows, that's weird. But as this developed more and more, it became clear that the universe is at least partially a combination of nature out there and our own consciousness. And so that's what this is all about. That's what biocentrism is about. And these books have been selling very well all around the world in many editions globally. And as strange as the idea sounds, it really appears to be true.
And that, ladies and gentlemen, was astronomer Bob Berman. And if you're interested in reading any of Bob's books, again, you can go to mysteriousmatters.com/Berman. And Bob's little show, 2 to 3 minute show, is Strange Universe, which you can find at mysteriousmatters.com/Strange Universe. And before I go, I want to say a special hello to all of my friends at paranormalforum.net. Well, ladies and gentlemen, until the next time we do come back together again, I hope you enjoyed this show. It's definitely been a while. I have appreciated doing this show myself. So, without any further ado, until the next time we come back together again, I bid you all a kind farewell.